What's going on, guys? Welcome back to another episode of Triangle Diagnostics. You can see behind me I have this 07 Scion TC. It's got the 2.4 liter engine in it. The issue with this car is the owner was driving this down the highway and it pretty much stalled out on him, and it wouldn't restart after that. They had it towed in. When I went out to inspect the vehicle, basically I had to put a jump box on it in order to start it. I noticed that when I did jump the car off, I had a battery light on the dash. And I had to keep the jump box on it to keep the vehicle running. That's basically how I got it into the shop here, guys. So I think the first thing I want to show you guys, I want to show you this thing running. I want to show you the battery light, just so you have a better idea of what we're dealing with. So that's coming up next. All right, so I'm inside the car here, guys. Inside this Scion. All I'm going to do is I'm going to start it up. I've already charged this battery, by the way. So we see the vehicle starts up. And the area we really want to pay attention to is here. As we can see, we currently have this battery warning indicator illuminated on the dash. So that's what we're going to be attacking, guys. Definitely some sort of charging system issue here. We also noticed the check engine light is on. I know for a fact it has an EVAP fault code in here. I actually just fixed that. But anyways, we're going to get a scan tool on here. We're going to see if we have any charging system related trouble codes. And depending on if we do or not, we'll choose a direction to go on. Alright, guys, we're just in the scan tool menu here. I've got the key on currently. So what I'm looking for is Scion, this obviously being a Scion TC. And there's our guy right there. You gotta be kidding me. Alright, guys, so I've got the vehicle identified here. So yeah, 2007 Scion TC 2.4 4-cylinder. Just gonna hit OK here. I'm gonna do a full system code scan. I want to see all fault codes we have in the system. And really, what I'm looking for is anything that potentially pertains to the charging system. Anything other than that, really, we're just going to ignore it for the time being, guys. As I stated before, I know this has a EVAP fault code in it. It had a small leak. Needs a canister. No big deal on that. That's not our focus here. Our main focus is what's going on with this charging system. So looks like we have some engine codes here. We see some a few different EVAP codes. Again, we're not concerned about those. I'm just going to continue scrolling here, see what else we have throughout the system. We have a 2 low or 2 high battery bolts here in the ABS control module. Some more EVAP stuff, and that looks like the end of our list, guys. So scan tool doesn't look like it's going to help us on this one. So our next step is going to be to go straight to the vehicle and let's start doing some basic charging starting system tests. Alright, guys, so all I'm going to do here to do some basic initial charging starting system tests is I've just got the Vantage here, and what we're currently hooked up to is directly to the battery. If we look at this voltage number, we can see 12.4 volts. So this battery is slightly discharged, but not too bad, guys. What I want to do at this point is I want to start the vehicle up, and then I want to see what our charging system number goes to. So I'm just going to run around here to the car, and I'm going to crank this up for you. As we can see, guys, this vehicle is now running, and we currently have this voltage number of 12.27 volts. Let me try and get that a little bit more visible for you guys. Yeah, you can see a little bit better now. So 12.27 volts here, guys. This alternator is not charging whatsoever. Really what we need to do at this point is we need to start attacking this alternator as the cause of this battery light and this stall while driving down the highway. Clearly it's a charging system problem, guys. So the next step for me, in lieu of this very low charging system voltage number, is we're going to pull a diagram, determine how this alternator is controlled, and we're going to begin doing checks directly at the alternator. Alright, guys, so all I've done is I've pulled a diagram of this alternator. And really what we need to determine is how is this alternator controlled, what's controlling it, how does it work, and that's really going to be the basis of our troubleshooting. I've already went through this diagram and I've kind of highlighted some areas. Any area that I've highlighted yellow on this diagram is a power feed directly to the alternator from a fuse or something like that. And anything I've highlighted in purple is going to be something that's normally grounded. So I'm just going to start left to right on this diagram, guys. and I don't know if you can see, but this first pin here, this pin B, this is a black cable, and if we follow that, it comes up to this alternator fuse. It's 120 amp. What that's going to be, guys, is that's going to be the heavy cable going to the alternator. So we know that anytime, at any time we should have battery voltage here. So I've highlighted this yellow because of that. If we move over one, we see this IG terminal on the generator. If we follow that up, it goes through a junction here, this J1 and J2, and it continues going up to the top of the page. If we zoom in on that, we can see that is a fuse, a 7.5 fuse. ECU IG is what they're calling it here. And we can see that it's hot and on or start. So with this vehicle running, guys, it's definitely going to be a power feed. Just moving one over, we can see this wire here that I've highlighted yellow. If we follow this up, it goes to the instrument cluster. And we see it goes through this light emitting diode as well as this current limiting resistor. And then it continues to go up to this fuse here. This is a 10 amp fuse. They're designating it MET-IG2. What this is going to be, guys, is this is going to be the ground side control for the battery warning indicator inside of the instrument cluster. So when this generator assembly senses a fault, basically what it's going to do is supply ground on this wire. That's going to illuminate that LED in the cluster and signal to the driver that, hey, we have some sort of charging system issue. So just currently I've highlighted this purple for that reason, because with the battery light on the dash, we are going to see 0 volts on this wire. It is going to be grounded from the alternator. I'm going to skip this next wire here. We're going to talk about that in a second. I'm going to go over to this white wire now. If we follow this wire, it goes up all the way around the page, and then it goes to this Alt-S fuse. It's a 7.5 fuse. And that's going to be hot all of the time. It comes directly through the battery through this fuse. So we also know at all times we should have a power feed present here. Now the last thing I want to talk about pertaining to this alternator is if we look here on this yellow wire, we can see this terminal M, and this terminal M number goes up to the powertrain control module. This is going to be some sort of module-to-module communication, guys, some sort of signal. I'm not sure exactly what we're going to see. It's definitely a square wave. I'm also not certain what the alternator is using the signal for. Is this a signal from the engine computer to the alternator to control charge rate? Is this some sort of communication line from the alternator to the engine computer to signify some sort of fault? Or maybe some sort of current monitoring type of feedback signal? I'm not sure, guys. But what we're going to do is we're just going to proceed to the car, and we're just going to start attacking the rest of these that we know what they are. So we're going to get voltage measurements on all the rest of these, make sure we're good around the board, and then we'll focus more on this communication wire that we're not exactly sure about. So get into the car next. Alright, guys, so just some initial views of this alternator and where it lives in this car. It's right here directly beside the exhaust manifold here on the front of the engine, just for some better perspective getting there, guys. So if we look at this alternator, what we can notice is we have 2 connectors here. We have this one connector. It has 4 wires coming out of it. I've just kind of pulled this insulation back, and you can see I already have a T-pin here where I was doing some testing earlier. But if we look at this other one, this is going to be the heavy cable. This is going to be off of that 120 amp fuse that we saw before. So really 2 different connectors we need to be worried about here, guys. For simplicity's sake, we're going to start with this heavy one, and we're going to make sure we don't have any excessive voltage drop issue on this one. And then we'll move on to the smaller connector, which is going to have all of those other control wires there. So I'm going to get that set up, and we'll go from there. Alright, guys, so all I've done is I've just put my positive test lead directly on this cable here at the alternator. We can currently see a reading on the Vantage of 12.53 volts. What that signifies is that this big heavy fuse is currently not blown, but really this isn't a good test, guys. There's really no current flow going on here in this heavy cable. So what we need to do to be 100% about this positive post, as well as all of the other measurements we're going to do on this car, is we need to start it up and we need to run it. So all I'm going to do is we're going to stay focused on this, and I'm going to start this vehicle up, and then we're going to double check our voltage measurement here to ensure that we still have that good strong battery feed, and then we're going to compare that to the battery positive post directly. So I'm going to start it up now. So as you guys can see, we have the vehicle running now. It kind of looks like my lead's laying on the exhaust manifold. Don't worry, it's not. If we look to the Vantage, currently what we have is this 12.2 volt number. So we definitely still have battery voltage there. In order to do a voltage drop test of this, to make sure we don't have any corrosion issues in this heavy cable, which really based off of this measurement, we kind of know that there's not. I'm just going to move this lead directly to battery positive. And you can see we currently have this number of 12.26 volts. I'm just going to move this back. And we're reading 12.23 directly at the alternator. So absolutely no voltage drop issue there, guys, whatsoever. So we know for a fact this positive cable is good. So the next thing I want to do, just because it's pretty easy, is I want to do a voltage measurement of the alternator case itself. What that's going to tell us is that this alternator ground is good. And all I'm going to do this is I'm just going to find some sort of place that's metal and easy to clamp around here on this alternator. I may be able to use this bracket since it's directly screwed to it. And if we look on the Vantage, what we see is this 0.04 volt number. So that's difference of potential between battery ground and this alternator case. Absolutely nothing wrong with the ground, guys. So what we need to start attacking next are the smaller wires on this other connector. Alright guys, so I don't know how well this is going to show up. What I have here is I have the diagram right here so we can use this as our guide when we're testing the smaller connector. And obviously we still have the Vantage here. So all I'm going to do, guys, is I'm just going to go left to right. I'm going to start with this this IG indicated one. This is our black wire that comes up to this 7.5 amp ECU IG fuse. And all I'm going to do is I'm going to find that wire. It's red, directly at the alternator. And I'm just going to back probe it. And then I'm going to move my positive lead to that location. If we take a look at the Vantage, guys, we see 12 volts. So we can cross that one off our list. Absolutely nothing wrong with this IG indicated wire. That's going to be this one right here. We've already checked this big heavy one, this one to the left here. So the next thing we want to check is we want to check this L terminal wire. That's going to be the ground side control from the alternator to control the LED inside of the instrument cluster. They're designating this wire as pink. Just taking a look here. This pink wire is in this the top left of this connector, guys. Just looking directly into that. And what we can see is this low voltage number, 0.04 volts. That's currently grounded, guys. The alternator is grounding this. What we're going to do real quick is I'm going to bring you guys and set you up in the vehicle so you guys can monitor this battery lamp. See if I can get you guys set up here some type of way. Alright guys, so I've got you guys set up looking at this battery lamp. All I'm going to do is I'm just going to go outside back to that alternator. I'm going to unplug that smaller connector. What should happen is this battery light should go out. So I'm just going to do that now. As you guys can see, with the alternator unplugged, that battery light extinguishes. The alternator is no longer grounding that circuit. This confirms also that there is no short to ground on this circuit. I'm going to go plug it back in. And as you can see with this alternator plugged back in, that light has re-illuminated. So what this tells us is this black wire, this pink wire going to the alternator for this lamp control is functional. The circuit is good. So we're going to continue moving on. Alright guys, so just continuing on with our testing. We just got done testing this LED control wire for this battery warning indicator on the cluster. So the next thing we're going to check is this last power feed. This is this white wire here. And it comes all the way around to this alternator S fuse, a 7.5 amp fuse. So I'm just going to find that on this connector here. And we're going to back probe that. It is on the bottom right of this connector. Putting my T-pin in that. Hooking my lead up. And as we can see by the vantage, we also have battery power here, guys. So as far as all of our fused controls to this alternator, they're all looking good. The only thing we really haven't tested to condemn this alternator at this point is this this signal wire coming from the generator to the engine control module. Like I said before, I'm not sure what it's doing with this, but what we're going to do is we're going to get a lab scope hooked into it, and we're going to see what sort of signal we have. So this is the wire here that we're hooked into, guys, this yellow wire. It goes directly from the engine control module to the generator terminal M. Like I said, I'm not sure what this one is. This is how we're hooked into it. Just got a T-pin going to the back of that smaller alternator connector, and I've already got it hooked up. And it's still rolling, obviously, here. Let me get you guys focused on the vantage. So as we can see, we have the square wave rolling on the screen right now. It's a pretty fast signal. This is about a 200 millisecond screen here, guys. And what I'm seeing is I'm seeing about a 0 to 12 volt square wave on this. Let's see if I can get you guys out of the glare. There you go, that's a little better, huh? So about a 0 to 12 volt square wave on this, guys. I'm not sure what exactly this signal is or what it's doing. I'm also not sure where it's coming from. So to kind of get a better idea of that, all I'm going to do is I'm going to unplug this connector and determine circuit design that way. So I'm just going to unplug this alternator connector and see what this number does. And we can see that it went to this flat line 11.3 volt number. What that tells me is that the engine computer is sending this 11.3 volts to this alternator, and this alternator is modifying, basically duty cycling this signal to perform something. What it's doing, I'm not sure what. I'm going to plug it back in. When you see that signal comes back, this alternator is definitely doing something with this signal, guys. I'm not exactly sure what it's doing, as I said before. We didn't have any sort of generator fault codes or anything like that in the engine computer, so not 100% on that. We can do some experimentation. What I'm going to do is I'm going to back out of this lab scope function. And really what I want to do at this point is I want to pull our digital multimeter up. And I want to look at duty cycle. Doesn't look like it's giving me an option to do it here for some reason. Let me go back. Let me go to the graphing meter because I know it's in there. Let me see here. So we'll do duty cycle first, guys, just to see what the on time really of this signal is. And our live number is right around 29%, so 29% duty cycle. One thing that we can do here is I'm going to turn the lights on and generate some sort of electrical load on this car. And let's see if this number changes. Hopefully you guys can see that 29.2% number there. So I'm just going to turn some lights on. So I've got the lights on, the high beams are on, the blower motor's on, and we can see not really any change in this signal, guys. We're still around this 29.3% duty cycle. So not a big help there. The next thing I want to do is frequency. Still using the graphing meter here. This thing's starting to run a little shaky, guys, as this battery starts to die. So we're choosing frequency now. Currently our live number is about 200 hertz. Hopefully you guys are still on that. So this cycle's happening 200 times per second. I'm gonna turn all these loads back off and see what happens. Alright guys, so that's all loads off, lights are off, blower motor's off, all that. Really no change there. So I'm not sure what the signal is, guys, to be honest with you. I think maybe what we should do at this point is visit the troubleshooter in the Verus and see if it gives us any information. One thing I can say is I've already looked for this info just using description and operation for this alternator, and I was unable to find anything pertaining to it. So currently I don't really have an answer to you guys. We definitely didn't see any sort of change, whether duty cycle or frequency wise, in that signal through different loads. So currently don't really have an idea. What I do know is wiring integrity from the engine computer to this is good, based on the fact that the engine computer is sending 12 volts to this alternator. So really at this point, guys, I'm confident in calling a bad alternator. We verified everything on this alternator to ensure we didn't miss anything, had any wiring problems, had any computer control problems. We don't. So that being said, definitely a bad alternator here. Before we wrap this video up, let's visit the troubleshooter function in the Snap-on Verus and see if it gives us any more information on what this computer signal we're seeing here actually is. So that's coming up next. Alright guys, I'm on the home screen of the Verus, and I'm just going to go to this guided component test meter here. And this is a US import 2.4. We already have the Scion loaded. I'm going to click OK. And what I'm looking for here is this charging system. And it's not looking like we're going to have much available information here, but we'll click through some of these and see if we can figure anything out. Nothing really here, guys. It's just doing voltage drop testing of the ground. This is just some terminology stuff that's not going to help us. Looking at this current ramp. Yeah, nothing really of note there, guys, either. And then some abbreviation stuff. So this isn't going to help us, guys. No information really pertaining to this alternator here either. Maybe what we can do is go back to the scan tool and go to the engine, and then maybe use the troubleshooter feature. Maybe we can get something that way. We're going to go to symptom tips, warning lights and alarms, and I don't really see anything here. Let me see, maybe starting problems. Yeah, nothing really here. We'll try starts and dies. Nothing really there, guys. Not a whole lot of information for these Japanese imports sometimes through the troubleshooter function. The Verus really is great for anything domestic, but when you start getting into Japanese, any sort of imports, it becomes less of an effective tool, but still a very effective tool. In this case, we weren't able to find any more information on this, but it was worth a shot. We didn't find anything, but definitely worth a shot. So yeah, guys, that's pretty much it. We covered this one pretty quick. Some pretty basic checks on this alternator. Again, the symptoms with this vehicle is they were driving it down the street, and it just stalled out and died on them. The battery was completely dead. They couldn't recrank it. They got a jump, drove it for a little bit longer, stalled out again. That's when they had it towed here. When I initially inspected this vehicle out, I did have to jump it to get into the door. The battery light was illuminated all throughout that. But basically all we covered was some pretty basic charging system tests and how to really identify a faulty alternator here. I wish I had an answer for you guys as far as that communication line from the engine computer back to the alternator. I really don't know what the engine computer is doing with that signal. We definitely know circuit design for sure. It's definitely a 12 volt pull down circuit. So the engine computer is going to send 12 volts to this alternator, and the alternator is going to pull it to ground. We were seeing a frequency of around 200 hertz or so 200 times per second, pretty fast. I really don't know what it's there for, to be honest with you. I did some pretty extensive research, description and operation wise, and that didn't afford me an answer. We looked in the Verus for any sort of information, through the troubleshooter as well as the guided component tests. No information there either. The only thing I could really think of is that potentially maybe if that signal were not present, the engine computer could flag some sort of alternator circuit trouble code. As I said, not sure, guys. What we do know is how to test it. Definitely a 12 volt pull down circuit So if you unplug that connector, you have 12 volts there. That really confirms wiring integrity from the engine computer without a doubt. So that's it, guys. 2007 Scion TC, bad alternator. Hopefully this helped you guys out. Hopefully you guys see this in the future. It'll give you some pretty clear answers on how to troubleshoot it. It's relatively simple design, real easy to get to, real easy to get T-pins in and stuff like that. But if you guys have any questions on this design, or you have any recommendations, any suggestions for your fellow technicians as well as myself, feel free to comment down below. But as for that, we're all done. This bad boy needs an alternator.